All right, welcome. Here we go. We're going to start a new section, unit, chapter. I don't know how you want to call it, but we're talking about parallel lines and transversals, which is the beginning of chapter 3, but this is the beginning of unit 4. So go with that. What you want to do here is you want to be able to identify relationships between two lines or two planes, and you also want to be able to name angle pairs formed by parallel lines and transversals. Or technically any lines and transversals, but that's a whole different story. So, more definitions here than anything else. I think this is one of those, when we work on it in class, you're going to see how to do the different things. But so I'm just going to keep this one kind of short and, well, just short and sweet. All right, let's go. Anyways, we need to know what a parallel line is. Key on this, coplanar lines that do not intersect. So notice here that we're saying now, we're talking about coplanar lines because we can have lines that do not intersect that are not coplanar, and they are called skew lines. Now, also notice here that I made this little arrow here. When you see like an arrow on two different lines, like a little arrow like that, that's noting that the lines are parallel. Also, the symbol for parallel is those two parallel lines or slanted lines. In the book, you'll see them up and down, so I guess maybe they're changing that, but I always used to see them as slanted. So, there we go. But when you see these little arrows like this, going like that, that's indicating the lines are parallel. Okay, so we have parallel lines and we have skew lines. And we also have parallel planes. So if you go back to this example here, let's try that again. That was the worst arrow there. Okay, this example here, planes A and B are coplanar. Parallel. So those are parallel planes. Okay, and then also, what is a transversal? A transversal is a line that intersects two or more coplanar lines. So notice there, we're saying that if two lines are on a same plane and there's a line that goes through them, that's a coplanar. A transversal. Coplanar just means they have to be on the same plane. They don't have to necessarily be parallel. So you can see here, I'm going to put here line M, this line right here, but you get the idea, that is a transversal through the other three lines, even though this line, let's call that one N, is not parallel to the other two. And I would make note that these two are parallel with those little arrows. Anyways, so you kind of get the idea there. Those are words and definitions you should know. And then you need to know about transversal angle relationships. So you see this little drawing here, and this is located on page 174. Page 174, if you want to copy it from there. But basically, here we go. We have what are called interior angles, exterior angles, consecutive interior angles, alternate interior angles, alternate exterior angles, and corresponding angles. And we will have some exercises that goes through all of that to kind of reinforce that. So let's look at maybe an example. Okay, so let's use this drawing here. I couldn't get a really good picture of that, so you just kind of got to go with it. But it's basically a cube. And I want to name all segments Skew to B and C. In other words, all the ones that are on different planes that do not intersect and are not necessarily parallel. Well, obviously, if they're not intersecting, they're not on the same plane. So, like, for example, if you look here, if BC is right here, and then I go AF, line AF is skew. Line DE is skew. They will not intersect with BC. Line FG is skew. So they're not parallel, they're not going to intersect, and they're not on the same plane. And line HE. Okay, so the key there is trying to make sure that they are not they do not intersect and they're not on the same plane. So we're trying to say that they're not, say, parallel. Also there, but the main thing is they're not intersecting, they're not on the same plane. So kind of go with that. All right. Okay, name segments parallel to EH. I'm not going to try to name them all, but we're going to try to name some. So here's EH right here. And parallel to that, obviously you can see FG. That one's kind of easy. It's right there on the same plane. You can see DC. That one's also pretty easy because they're on that side plane together right here. Now, the one that might get some people is like, say, AB. They don't look like they're on the same plane, but keep in mind there could be a plane that could connect these two like that, and thus that would put them on the same plane. So basically, you can't just go based on the shapes that you're seeing, because we can have like what I would call invisible planes. What? Are you talking about Wonder Woman's jet? No, I'm not talking about Wonder Woman's jet. But you kind of see that idea. So those would be some examples of segments that are parallel. Now, let's add in here, what about parallel planes? Parallel planes, what if I wanted to put, and I'll just put this here and you can just add it under. Parallel planes to, say, DCH. So this one right here, what would be parallel to that? Well, the only parallel we have is this other one on the other side, so we can say plane, and as long as you have 3 points, but if you want to put all 4 points, that's fine. But here I'm going to put A, B, G, could have put A, B, F. I mean, if you want to put all 4 points just so you're safe, that's fine too. Alright, so we've got those, and now let's talk about some of those alternate exterior angle relationships. Actually, I'm going to stop there because I don't want to go too far, and like I said, I wanted to keep it short. But you can we'll talk about the alternate exterior angles, all those different types of transversal angles in the lesson, so we can kind of go over that. But make sure, again, you have these properties here written down. Anyways, that's going to be it for today. Thank you so much for your time. Y'all been great. I will see y'all later. Take care.